Hi guys! Today is day 29 and day 30, and you will be solving quadratic equations using a separate method than what you did the past 2 days. We're going to be using the square roots to solve those quadratic equations. Alright, so when you do this, remember you still have something that looks like a polynomial, that it's in an equation, and your goal is to get a solution for x. Now, because we're using square roots, I do want to remind you we did a unit where we had to simplify square roots, and sometimes we had perfects and sometimes we didn't. So, if you happen to get to a point where you get the square root of a number that's not perfect, if you can simplify it just as we did in that previous unit when we were in school, simplify it and just leave it in its simplest form. And you're going to get down to a part where it'll look kind of funky because you'll have a number plus the square root of something, so on and so forth. That's completely okay. I know it looks funky, but just remember, we want it in its most correct and its simplest form. All right, so I'm going to have you jump over to this video real quick, check out the instructional lesson, and then I'll get back to you. Solving quadratics using square roots. So you all know what square roots are at this point, and we're going to put them to play in the form of an equation. All right, so I'm not going to use the note or the example in your notes, but I would advise that you make sure you have those notes and you also get your textbook out if you don't already have that. I'm going to go through written steps. Your notes may not have it exactly like I'm going to say it, so write down anything that you find would be helpful to you. All right, so the example I'm going to give you, I have 2x squared minus 32 is equal to 0. And I have a quadratic equation that I want to solve for its two values. Now, one thing that I missed in the last video is this is considered a quadratic equation not just because it's a non-linear equation, but what makes it non-linear is this x squared, which we did talk about, but this is called the quadratic term. My first term that's squared is the quadratic term, and that'll come into play in just a minute. So I'm giving you this equation and I say I want you at some point to be able to use a square root to find the two solutions. All right, so my very first step here, okay, so my step one, I'm going to isolate the quadratic term. So my quadratic term is 2x squared. And to isolate that term, it just means I'm going to use the inverse operation to move the negative 32 to the right side. All right, so we all know how to do that. I'm going to take 32, I'm going to add 32 to both sides, and then I'm dealing with the equation 2x squared is equal to 32. All right, and then it's almost isolated, but that coefficient of 2 is still something that I can move. So I'm also going to get rid of 2 by dividing both sides by 2, and then I have x squared is equal to 16. All right, everybody should be good at this point. We've done inverse operations since August. All right, now I'm going to take, now I'm going to go to step 2, which is solving for x. So when I'm solving for x here, that is when this new method comes to play. I'm solving for x, but I'm solving for x when it's squared. So we've said this many times. What's the inverse operation of an exponent of 2? A square root. So if I were to solve for x here, I'd have to take the square root of both sides because the only thing that I can do to cancel out that exponent of 2 is to take the square root of the exponent of 2. And then if I take the square root of the left side of the equation, I most certainly have to do the same thing to the right side of the equation. All right, so make sure you write that little note somewhere. We're going to use the square root, or we should be using the square root at some point in this step. So when I do that, again, these guys cancel out, and I'm left with x, and then we know that the square root of 16 is 4. All right, so it looks like we're done, right? But I have a problem here. I just have x is equal to 4, and something's not right with that. So I want you to consider what two numbers I can multiply together to get 16. Well, most of you are going to say, well, 4 times 4 is 16. We know that. But negative 4 times negative 4 is also going to produce 16. So this is where a new little thing comes into play. I don't just have the possibility of having positive 4s. I have the possibility of getting negative 4s. So we would do what's called the plus or minus sign, which we've seen just a little bit. So, and that doesn't look like an equal sign, so let me fix that. So the solution here would be that x is equal to positive or negative 4. It's not just 1, it could be either one, or it is either one. All right, so then we're going to take that answer and we're going to put it into set notation. Let me move my magnets. I'm running out of room. There we go. So that would be your step 3 and your step 4. So step 3 is realizing that I'm going to have a positive or negative solution with whatever I do here. And then I'm going to put that into set notation. Not too bad, right? Okay. All right. So I'm back, and I'm kind of continuing with your notes. I just have a new example for you. I did write the rest of the steps over here. So I have a quadratic equation on the right. I know it's quadratic because once I take this binomial and I square the binomial, I would end up having x squared. I want to solve this quadratic equation using square roots. So our first step is we're going to isolate the quadratic term, which again, it would be within this binomial. I'll get to that a little bit more in just a minute. Then we're going to solve for x, and that means we're going to use the square root at some point. Then we're going to remember that somewhere in there we're going to have a positive or negative, and then finally our answer should be in set notation. All right, so step 1, we want to isolate that quadratic term. So our quadratic term isn't quite looking like a quadratic term because this isn't simplified. I don't want you to simplify it, okay? So don't overwork yourself. Just keep in mind we're going to treat this as our quadratic term because we know it would lead to x squared. So my next step is, the same step is to isolate that term that we just talked about. So I'm going to get rid of 2 and I'm going to get rid of 1 using the inverse operation. All right, so I have my quadratic term isolated, and it's equal to 36 at this point. Now I'm going to go to step 2, which is I actually want to solve for x. So when I'm solving for x, that means I need to get rid of this exponent of 2, and again, what cancels out an exponent of 2? A square root. So I'm going to take the square root of both sides of my equation, and when I do that, my square root and my exponent of 2 cancel, which leaves me with x plus 5 is equal to, it's not just 6 on the right side. The square root of 36 could be positive 6, but it could be negative 6. So we write plus or minus 6. Now what's different with this one? And our last one, as soon as we did this step, we were finished. But on the left side of my equation, I still have that plus 5. So that means that I'm still within the realm of steps 2 and steps 3. So I'm going to use the inverse operation to get rid of that -5. And then I suggest when you're doing these that you write them exactly how I'm about to do them. I have x is equal to ±6 minus 5. I write that because it wasn't that the overall answer was going to be positive or negative. It was the answer to the square root could be positive or negative. Then we're going to use the rest of this problem to figure out our two solutions. So I have, let me bring this over to the right side of the board. I have a +6 minus 5, and I have a -6 minus 5. So this would be 1, and this would be -11, which means that x is either, excuse me, my set notation, x would be my -11 or my +1. My curly bracket on the right looks really crazy. All right, so hopefully that feels a little bit better. Now keep in mind that you have a whole set of notes with a bunch of different examples. I'm getting those out right now. And there is one thing that I want to make sure that you feel okay with before I leave you astray. Okay, so if I ended up with the square root of a negative number, you can't have the square root of a negative number. So you would say that there's no solution, okay? And then the other thing is, if I got to this point and I wasn't going to get a whole number or something that was definitely the answer, leave it in this form so that it's in its simplest, most accurate form. All right? So with that being said, the next thing that you should be looking at is this page. This page has 3 example problems for you. It also has some information at the top that is beneficial for you to obtain. You may want to check out your textbook from that, but it's talking about how many real solutions that you would have if this answer, if whatever the number is underneath the radical was equal to 0, less than 0, greater than 0. So think about positives, negatives. All right, and then I did provide you with the answer key so you can check your work. And then finally is your assignment. So your assignment is, why didn't the mummy have friends? As you're solving, you'll see that there is a self-checking key at the bottom, and your rhyme at the bottom should make sense for the riddle of why the mummy didn't have friends. So, all right, I think that's it. All right, guys, so you watched the instructional video. Now you have a couple things that you have in your packet to look at. One is I gave you some practice problems just as I have the past week or so. I would suggest just doing a few of them. Make sure you feel comfortable with it, and then move on to your handout. It's called Why Didn't the Mummy Have Friends? It is self-checking, so if you get to a point that you don't see an answer, first look to see if it can reduce what your answer is, if it can reduce any more to get one of the answers that are on this handout. If not, if you're still getting something wrong or you're stuck, send me a message and I'll help you out. So you are almost finished, and hopefully, I know this one again is a little funky, but hopefully you get the trick. And then if you have any questions, reach out to me. I hope you all are doing well. I miss seeing you.